Okay. Here, carbon went from a 0 to a -4. So that means this right here is gaining electrons. So that means carbon is reduced. And then hydrogen is going from a 0 to a +1. So that is a loss of electrons. So that means oxygen is oxidized. I'm just writing it as an abbreviation because I don't have enough room. Okay. Once you label something as being reduced, you can now label it as being the oxidizing agent. And whatever is oxidized is the reducing agent. But it's helpful if you know what's oxidized and reduced first. Okay? If you want to abbreviate oxidizing agent and reducing agent, you can. You could abbreviate oxidizing agent as OA and reducing agent as RA. Okay? So now what I want you to do is I want you guys to do number 2 and number 3 and number 4. Label them with oxidation numbers, determine what's oxidized and reduced, and then label the oxidizing agent and reducing agent, okay? And let's see what you guys come up with. Okay, number 2. What did you guys put for strontium's oxidation number? This one right here. It's elemental form. So it would be what? 0. Okay. And then for the next one, iron does not have an assigned charge, so you want to assign bromine first. So bromine's usual charge is what? -1. So that means iron would be what? +3. Okay. And then over here, this is elemental iron, so it would be 0. And then strontium has an assigned charge. What would it be? +2. That means bromine would have to be what? -1. Okay, so as you read this from left to right, strontium goes from a 0 to a +2. Is that gaining or losing electrons? Losing. So this is a loss of electrons. So loss of electrons is? Oxidation. So strontium metal is oxidized. So that means that makes this the reducing agent. And then over here, bromine stays the same. So we don't care about bromine, but strontium goes from a +3 to a +2. So this is gaining electrons. So that means you would have to specify, since this is an ionic compound, the ion in the ionic compound that is being reduced. So Fe+3 is reduced, and that makes it the oxidizing agent. Okay, for number 3, I'm going to write the oxidation numbers underneath since I don't have a lot of room. What's the oxidation number for oxygen here? -2. What would carbon be? +2. Okay, and then over here, what would the oxidation number be for the oxygen here? -2. That means chlorine would have to be +5. And then over here, oxygen would be what? -2. Carbon would be +4. And this is elemental chlorine. So 0. Okay. So as you read this from left to right, carbon is going from a +2 to a +4. So that would be a loss of electrons, right? Because my oxidation number is increasing. Now, these are molecular compounds. So like this, 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 and this. These are all molecular compounds. And when you have a molecular compound, you want to say the entire compound is either oxidized or reduced because it's not made of ions, so I can't break it down. So that means here, CO is oxidized. Just say the whole thing because it's molecular. Okay? And then if that's oxidized, that means it's the reducing agent. Okay? Now, for oxygen, oxygen's number didn't change. So we do not care about oxygen at all. We want to compare the chlorines to each other. So this chlorine is at a +5. This chlorine's at a 0. So my oxidation number is coming down. So that means we are gaining electrons. And since Cl2O5 is molecular, you would have to say that the whole thing is reduced, rather than saying an ion in it, because there is no ion in it. And then you would say that it's the oxidizing agent. Okay? For number 4. What's the oxidation number for H here? +1. That means P would be -3. And then P4 is elemental phosphorus, so it would be 0. And then H2 is elemental hydrogen. 0. Okay, so P is going from a -3 to a 0. So this is a loss of electrons. And pH3 and P4 and H2 are molecular. So that means we would have to refer to the entire molecule as being oxidized or reduced. So that means pH3 is oxidized, and that makes it the reducing agent. Then hydrogen went from a +1 to 0. So it was gaining electrons. And again, we'd have to say that the entire molecule is reduced, because I can't refer to it as an ion because it's not ionic. And that means pH3 is the oxidizing agent. Yes? Okay. Your homework is open. You have 3 attempts to earn a perfect score. Okay.